We can read from a row, or we can write from a row. We can read from a column or write from a column. We can also clear the table or clear the row or the column. We can delete a row, and this is a nice tool because it will actually shift up the previous rows. If we delete row 1, row 2 will shift up to become row 1, row 3 will shift up to become row 2, and so forth. We can do a data table find, and a find extended gives us more search options. These are very nice tools if we, for example, create some kind of lookup table or a user database. One very nice example of this is a user database. If we want to have a username and a password, for example, we can have someone type in on the screen the username. It'll search the username and it'll return whether there is a username or not. And based on this, we can pull out a stored password, so we can cross-reference a password they type in on the screen as well. We can copy data table rows or columns, and we can store directly to specific cells. And we'll talk about this near the end when we go back to the data table editor. Okay. But in this case, we're going to use the write row. We're going to write a row which will contain the current date, the current time, the state of the 3 pieces of information at that time as well. And in order to do this, we need to have either some event-driven or time-driven function. In this case, let's use, again, a 1-second timer. But let's go ahead and show a simple way to create a different type of timer. We're going to start with an inverted contact, place it here in net 4. Now instead of MB, I'm going to select T for timer. Again, I'll grab the next unused timer, and we'll call this log timer. I'm going to give it a startup value of 1 second. Now you can say, well, why are we doing this? We have SB13. We're just trying to demonstrate here another time base, or rather, another way to create a timer that we want to use. And we'll explain that in a second. But we're going to now connect this to an output coil. And the coil will also be timer 0. Okay. Now in the net below, we're going to use a normally open contact, and we'll call this as well timer 0. So a quick rundown how this timer circuit works is when the timer bit value for timer 0 is low, the inverted contact of timer 0 will be high. This is going to drive timer 0 high. Once timer 0 goes high, the bit value for TD0 will be high. That will enable our TD0 normally open contact. When we come around the scan, our normally closed contact now be open, and it will disable the countdown timer. Since this timer is of the type TD, when we stop supplying power to it, the bit value will go low. TD0 here in net 5 will be low again. This contact will be low. And we'll come around, and the normally closed contact will be active again. So this timer will run around, and every second will pulse the contact that's linked to TD0, and it will open the inverted contact. So that being said, we can change the time value from 1 second to 2 seconds, or maybe 2.45 seconds. And now every 2.45 seconds, we will have one single pulse to output. This is a very powerful timer application. It's very simple. Truly, it adds 1 scan to the actual time base, but we can expect that to be somewhere in the milliseconds or tens of milliseconds. In this case, I'm sure it'll be 1 or 2 milliseconds. So it's really not increasing much to our time base. Let's go ahead and make it back to 1, 0, 0. We can display the time also in seconds, I should mention. We'll go ahead and leave it here. So we've created essentially SB13, but we've seen that we can create any time base function, repeating time base with the same period that we like. I'm going to go ahead and just increase the size of this net. So we have, again, data 1, data 2, data 3. We have our event, or I'm sorry, in this case, time-driven trigger. So we have left is still our date and time. Let's go ahead and click on strings and go to RTC to ASCII. Again, RTC is a real-time clock, and ASCII is how we store strings. So we're going to create a function that converts the real-time clock function to a string. And remember, we've set up our columns 0 and 1 as date and time, and we've called them a string type, so we can store this information into them. Of course, again, we have to decide that that's what we're going to do when we're defining our table. Let's look at the options we have here. So we can select the date or the time in many different formats. We want to use the date first, so I'll come down near to the bottom and select month, day, year. I think it's an appropriate format for us to use. Notice the information that we get from this description. It says 8 characters and null, which is 9 bytes, and which is also 5 MIs. Now, if we haven't worked with an ASCII string before, the basic idea here is that each character takes up 1 byte's worth of information, or we can store a representation of all of the characters on the keyboard, for instance, any number or letter. They each have their own ASCII code representation, a value from 0 to 255, and that means that we can store, in this case, in all cases, 2 characters or 2 bytes per 1 memory integer. So, what does this mean here? Month, month, slash, day, day, slash, year, year. That's 8 characters. And the null. The null is a very important idea when working with ASCII strings. The null is basically a 0 value. If we're defining a string, we define it by its maximum length. I'll give you another example. If we use an ASCII string to store people's names, we can have a very long first name and a very long last name and a space between them. Maybe we need 30 characters to represent or store someone's name. We can have another person with a short first name and short last name. Now, we don't want to assign different memory spaces or different vectors to store these names. So what we're going to do is store the information, again, from the start of vector, or the start pointer. We'll store all the pertinent information, and then we're going to store this null, or this 0, after it. So all of the tools that work with strings work from the start of vector, and then work and read or write till they reach this null. So specifically, if we're reading back, we're going to read all the characters of the first name, the space, the characters of the second name, and once we reach the null, we'll stop. This is a very nice function. Again, it enables us to write more than one specific piece of data to that memory location. So again, 8 characters plus the null is 9 bytes. If we're going to store this into a memory integer, we need to use, well, 4.5 memory integers. That doesn't really make sense, so we need to round up. So we need to set aside 5 memory integers to use. Okay. I hope that explanation made sense. There's certainly a lot more to talk about with ASCII strings and the string functions we have available, and the help file is a great place to read about those. But that being said, let's just go ahead and realize that when we use any of these functions, we need to look and see how many memory integers they require. The characters and the null, the amount of bytes, is all great information, but what it comes down to is we need to set aside 5 memory integers to use, and I should say 5 memory integers in a row or in a vector to use to store the date in this format. So let's go ahead and we'll click here, and I'll hit OK. Now, where are we going to save this information? I want to save it to, again, a vector with a length of 5 that starts at memory integer 10. Okay? Again, what this means is we're going to store the information to memory integer 10, 11, 12, 13, and 14. So start address, memory integer 10, with a length of 5, the following 4 registers. Now, one really nice tool we have is this one that says set features for a group of operands. I'm going to click it. We'll bring up another menu. We can type in under text a name, and under number of operands, we can set the amount of operands we want to give this description to. And of course, it's all going to work in a vector, starting at memory integer 10. Now, we know we need 5 operands, so let's go ahead and fill that in. The information here, decimal or hex, we're going to leave it as decimal. We can, if we wish, to give all of these power values. If we want to maybe clear them out to 0 before we start. In this case, it doesn't matter. again, the idea is that we're going to overwrite this string every time, every second, so the new data will be there. And since we're not going to do our logging function until after we've stored the data, it doesn't matter what was there previously. But let's go ahead and change this description to date. I'm sorry. And another nice tool we have is this insert parameter tool. Now let's go after date. We'll hit the space bar. We'll click this once. And notice we have our pipe with 3 zeros and the number 1. What this is going to do is sequentially number our give name to the description based on the start and then the next following. What this means is memory integer 10 will have the name date 1. Memory integer 11 will have the name date 2, and date 3, 4, and 5, and so on, based on the number of operands we're linking it to. Now this is nice enough in itself, but one more user-defined functionality we can add here is to declare the length of the string as well. So I'm going to hit space once and type of 5. And what this does is makes it easy for me as the user or someone else who's looking at my application to know the length of the string. It's good enough to give it this description with the number of operands, but it's better in terms of usability and functionality of us, the user or programmer, to give it this naming convention. Okay. I'm going to hit OK here, and I'm going to hit OK here. And now let's take a look in our navigator. We'll select memory integer, and we'll see memory integer 10 is date 1 of 5, 11, 2 of 5, 3, 4, and 5 of 5. It's been named sequentially, and we defined only the first one. Notice as well that this box here called use is also checked. This means when we use that get next unused variable, it looks at this checkbox to grab the next unused variable. Now if we declared a name for only memory integer 10, date, and we called it date, if we accidentally or inadvertently wrote new information, different information in memory integer 11, we would screw up our date. We would have things there and maybe they wouldn't even make sense as ASCII characters. So maybe we would have had, for instance, today's date 01 and then some number that would mean nothing to us. We need to make sure that we maintain this vector and we don't overwrite anywhere in the middle of it. And that's not just true for this RTC function, that's true for all string functions. Okay. So, that being said, we have our date. Let's go ahead and don't forget to connect these elements here. Let's do this again for the time. So again, string, RTC to ASCII. And this time we'll select a time format, maybe hours, minutes, seconds. Again, 5 memory integers, 8 characters in the null, 9 bytes. And this time we're going to link it to memory integer 15. And of course, I planned this out. I knew we were going to use 5 integers, so it's nice to have our memory integer 10 and memory integer 15. Again, I'm going to change this to 5. I'm going to get rid of the automatic definition. We'll type in time, hit space, insert parameter, hit space, and type of 5. Okay.